Welcome back to Engineers Academy. If you haven't subscribed my channel, kindly subscribe my channel. Now I am going to solve this example 12.9. This is based on the curvilinear motion, that is the rectangular components. So in this problem it is said that at any instant the horizontal position of the weather balloon in this figure is defined by x equals to 8t, right? So we are given the position along x. This balloon is moving in the x and y direction, right? So in these coordinate system, in x and y coordinate system, right? So we are given the position of the balloon as a function of t, right? So x is given as a function of t, right? So x is equal to 8t feet. So the motion of a balloon along x is given as a function of t, and similarly the motion of the balloon in the y direction is given as a function of x, right? So the y of this the motion of the balloon along y is given as a function of x, so it is given as y of x, which is x squared divided by 10. And we are asked to determine the magnitude and direction of the velocity and the acceleration when t is 2 seconds, right? So we have to find the magnitude and the direction of the velocity as well as the acceleration, right? So now as we know that the velocity of the balloon will be equal to Vx square, the magnitude will be equal to Vx square Vy square under the root, right? So first we have to find Vx. So Vx will be equal to dx by dt, which is equal to x dot, right? So this means that Vx will be d by dt, and the x function is given, which is 8t, right? So I will put 8t, right? So then this means that Vx will be, if we take the derivative of this, so then this will be only 8, right? So this means that this is feet per second. So Vx is 8 feet per second at time t equals to 2 seconds, right? So the velocity along x is constant, right? So it is not changing. Similarly, if you want to find Vy, right? So Vy will be equal to dy by dt, right? And since this y is given as a function of x, so then we will apply the chain rule, right? So to find this dy by dt, and y is a function of x, right? So we cannot take the derivative of this y functions with t, right? So we cannot take the derivative of dy by t directly. This is not possible since y is a function of x. So what we will do is that we will apply the chain rule. So first we will find the derivative of y with respect to x, and then we will find the derivative of x with respect to t, right? So this is the chain rule. So this will cancel out, and then we will be left with what? So we will be left with dy by dt, which we are finding, right? So Vy will be dy by dt. So now we will apply this chain rule, right? So Vy will be equal to, so dy by dt. So if I write, so then dy by dx, so d by dx, and y is x squared divided by 10 multiply by d by dt, and we have to take the derivative of x, which is 8t, right? So now when we find these derivatives, so then this will be 2x by 10 into this will be 8. So now as we can see that this is 16 divided by 10, so this is 1.6x. So this is the velocity along y, right? And this is a function of x, right? So we want to find the velocity Vy at time t equals to 2 seconds, right? So now first we have to find x at t equals to 2 seconds, right? So x is equal to 8t, and x at 2 seconds will be 8 times 2, which is 16 feet. So at 2 seconds the balloon will be at a distance of 16 from this origin along x, right? So this is the position along x after 2 seconds, right? So then Vy will be equal to this 1.6 into this 16 feet, right? So this will give us Vy after 2 seconds. So let me find this. So Vy comes out to be 25.6 feet per second, and this is at t equals to 2 seconds, remember, right? So this is Vy. So now we know Vx and now we know Vy, so we can find the velocity magnitude, right? So the velocity magnitude will be equal to Vx square plus Vy square under the root, and this is Vx, right? So Vx is 8, so 8 square plus 25.6 whole square under the root 2. So this will give us the velocity magnitude. So this comes out to be 26.82 feet per second. So this is the velocity of the balloon after 2 seconds, right? And we have to find the direction, right? So first let me draw that velocity vector, right? So when t is 2 seconds, so x is 16 feet, right? So this means that the balloon will be at a 16 feet distance from this origin, right? So we have this 16 feet, so this is the balloon distance, right? And when x is 16, so then we can find the y coordinate of this point B, right? So the x coordinate of this point B is 16, so this balloon is at a distance of 16 feet along x, and we can find the y coordinate of this point B. So what will be the y coordinate? So y is a function of x, right? So y is x square divided by 10, so y equals to, so this is 16 square divided by 10. So this comes out to be 25.6 feet, right? So this means that this balloon will be at a distance of 25.6 when the time is 2 seconds, right? So the coordinates of this point B are 16 feet and 25.6 feet, right? And this is the path of this balloon, right? So that velocity will be tangent to this path, right? So if I draw that velocity vector, let me draw that velocity vector. So it will be tangent to this path and it will be acting in this at this point B, right? So let's say that this is that velocity direction. Let's say that this is that velocity vector, and this velocity vector has two components, right? So one component is along x, one component is along x, and one component is along y. And the x component is Vx and this is the y component is Vy, and both are positive, right? So now if you want to find the direction of this V, so then we will find this angle theta, right? So then if we draw the triangle from this, so then this is the velocity vector, this is Vx, and then this is Vy, right? So V will be the summation of these two rectangular components, right? So then this is theta. So if we want to find theta, so then we will apply tan theta. So tan theta will be equal to Vy divided by Vx, and theta will be equal to tan inverse, and Vy is 25.6, right? So I will write 25.6 divided by Vx, which is 8, right? So this will give us theta. So this comes out to be 72.56 degrees with the horizontal, right? So this theta is 72.56 degrees, right? So this is the magnitude of the velocity, and it is making 72.56 degrees with the horizontal. Now to find the acceleration magnitude, so then acceleration magnitude will be equal to ax square plus ay square under the root 2, and as we know that ax will be equal to Vx dot and Ay will be equal to Vy dot, right? So now we have Vx. Vx dot means d by dt of Vx, right? So Ax will be equal to d by dt of Vx, right? So this is Vx. So Vx is 8, right? So if we take the derivative of 8, so this means that Ax is 0, right? 0 feet per second square. So this means that the balloon is not accelerating along the x direction, right? Since the velocity is constant in the x direction, right? So this Vx is constant. So when the velocity is constant in x direction, so this balloon will not accelerate in the x direction. And similarly, this will be equal to d by dt Vy, right? So Ay is equal to d by dt, and again is we can see that Vy is a function of x, right? So Vy is a function of x, so then we have to apply the chain rule, right? So this is dVy, right? In other words, we can say that Ay is equal to x double dot. Sorry, in other words, we can say that Vy is equal to y double dot, right? So if we take the double derivative of y function, so then we will get the Ay, or if we get one derivative of y, so then we will get the acceleration along y. So now this is Vy, which is 1.6x, so then dVy by dt will be equal to dVy by dx multiplied by dx by dt, right? Since the Vy is a function of x, so again the same formula, right? So let me clear this board as well. So now if we apply this chain rule, so then this is Ay, right? So Ay equals to d by dx, so I will write d by dx and Vy, this is 1.6 x multiply by this dx by dt, right? So dx by dt is x dot, right? And we can write it like this. So this is Ay, and the derivative of this is 1.6, and x dot is what? X dot is Vx, right? So x dot is Vx at 2 seconds, right? So Ay equals to 1.6, and we are finding the acceleration after 2 seconds, right? So since Vx is constant, so then we will put that value directly. So then Ay will be equal to 1.6 multiplied by 8. So I will write 1.6 multiplied by 8, which comes out to be 12.8 feet per second square. So the balloon is only accelerating in the y direction. So now if we draw the acceleration vector at this point B, so let me remove this, and if we draw the acceleration vector at this point B, so then that vector, that acceleration is acting vertically upward, right? So this is the acceleration, this is the acceleration vector, right? And the magnitude of the acceleration will be, if we put the ax is 0, right? So ax is 0, so then we will be only left with ay, right? Ay square, and under the root will cancel out the square. So now the acceleration is equal to ay, which is 12.8 feet per second square. And if you want to find theta, so then that theta is 90 degrees, right? And if we apply the tan theta formula, so then theta will be equal to tan inverse ay divided by ax, and this will be tan inverse, and ay is 12.8 divided by 0, so this will become 0, and tan inverse 0 is 90 degrees. So this gives us 90 degrees, right? So the magnitude, acceleration magnitude is 12.8 feet per second square, and its angle with the horizontal with the positive x-axis is 90 degree. So this is the solution of this example. Now I am going to solve this next example. So in this example, it is said that for a short time the path of the plane in figure this 1219a is described by this function, right? So we are given the path is a function of x, so y of x is equal to 0.001 x square, and it is said that if the plane is rising with constant upward velocity, so this means that Vy is constant and Vy equals to y dot, and this is constant, and that constant velocity is 10 meter per second, right? So the plane is rising with constant upward velocity, so the upward component of the velocity is constant. So we are asked to determine the magnitudes of the velocity. So we are asked to find the velocity magnitude, which is equal to Vx square plus Vy square under the root 2, and we are asked to find the acceleration magnitude, which is Ax square plus Ay square under the root 2. and we are asked to find this velocity magnitude and acceleration magnitude at y equals to 100 meter, right? So when y equals to 100 meter, so we can find that x coordinate, right? So x square, so then x square will be equal to 100 divided by 0.001, and we can take the under the root, so that will give us the x coordinate. So when y is 100, so then x is 316.22 meters, right? So when y is 100 meters, so then the x coordinate of this plane is 316.22 meters. Now we are given this, so if we want to find the Vy, we are given this magnitude, right? So if I take the derivative of this, so this we have to find dy by dt, which is equal to y dot, but y is a function of x, so then we have to apply the chain rule, right? So how to apply the chain rule? So first we will take the derivative of this with respect to x, so this will be dy by dx, and then we will take the derivative of x with respect to t, so this will cancel out and we will be left with dy by dt. So then this means that y dot will be equal to d by dx, and this is 0.001 x square into dx by dt. So dx by dt is x dot, right? So we can write that y dot, and this, if we take the derivative of this, so this will be 2 into this 0.001, so this will become 0.002 x into x dot. So now we are given this, the upward velocity is constant, so y dot is given, so we can write 10, y dot is 10 meter per second, 0.002, and when y is 100, so x is 316.22, right? So we can put that as well, so this 316.22 x dot. So we can find x dot by using this Vy, which is given, right? So x dot, which is Vx, is equal to 10 divided by 0.002 into 316.22. So this will give us the velocity component along x. So Vx comes out to be 15.81 meter per second when the plane is at a height of 100 meters, right? So when y is at y equals to 100 meters, right? So now we have Vx and Vy, so we can find the magnitude of the velocity. So V will be equal to Vx square, which is 15.81 whole square, plus Vy is given, this is 10, so 10 square under the root. So the velocity magnitude is equal, so this comes out to be 18.71 meter per second. Now to find the acceleration magnitude, we have to find a x, which is equal to x double dot, and a y, which is equal to y double dot, right? So now we have this y dot, so y dot is equal to 0.002 x dot, right? So we have to find the time derivative of this y dot again, so we have to find this y double dot, right? So y double dot will be equal to 0.002, and we have to take the time derivative of this x dot. So y double dot will be equal to 0.002, and we have to apply the product rule now, right? So then this will be x d by dt x dot plus x dot d by dt x. So then this will be y double dot 0.002, this is x, and this will become x double dot plus x dot, and this dx by dt will become x dot again, right? So we can write it like this, so y double dot is 0.002 x double dot is ax, right? So we can write that this is ax plus x dot square, this is x dot square, and x dot square, so Vx is equal to x dot, right? So this means that x dot square is Vx square, so we can write that this is Vx square, right? So and we want to find the acceleration when y equals to 100 meter, right? So now we know that Vy is given, that the aeroplane is having constant velocity in the y direction, right? So Vy is constant. So this means that when the velocity is constant in the y direction, so then Ay will be constant, right? So if we take the derivative of this, so if we take the derivative, Vy, which is equal to y dot, is equal to 10 meter per second. If you want to find double derivative, so then this will be Ay. So if we take double derivative, so then this becomes 0. So this means that the Ay component of the acceleration is 0, right? So we can put it 0 here as well. So this is 0, which is 0.002, and when y equals to 100 meters, so then the x is 316.22. So we can put x equals to 316.22 in this equation, right? We want to find the acceleration when y equals to 100 meter, right? So this will be 316.22 into ax plus vx. So we have this vx when y equals to 100 meter, right? So we have this value. So this will be 15.81 whole square. So now we can find the ax component of the acceleration by using this equation. So if we divide both sides of the equation by 0.002, so this means that 316.22 ax plus 15.81 whole square will be equal to 0, and ax will be equal to minus 15.81 whole square divided by 316.22. So let me find this. So ax comes out to be minus 0.791 meter per second square, and as we know that Ay equals to 0 now, so now we can find the acceleration magnitude. So what will be the acceleration magnitude? So we can put the values directly in this equation, right? So ax is 0, Ay is 0, and ax is minus 0.791 whole square plus 0 square under the root. So this means that the acceleration magnitude will be minus 0.791 meter per second square, right? So now if we draw the velocity vector at this point, so this is the path function, which is y of x, and the velocity will be tangent to this curve, right? So this is that velocity which is tangent to this curve, and this velocity has two components. One is vx and the other one is vy, and the ax component is negative, so the acceleration is only in the negative x direction. So this is the acceleration vector which is in the negative x direction, and the ay component of the acceleration is 0. So this is the solution of this second problem, this second example.